What's going on, everybody? Boris here at the Ecology Design Studio. This is the first part in what I hope will be a long and extremely thorough Java programming tutorial series. I'm calling this a learn along because I'm not a Java programmer and I will be learning the language alongside with you. Think of this as a Let's Play series where instead of a game we've never played, we tackle a different piece of software. For this series, I will be using Netbeans IDE, or Integrated Development Environment. We start at the very beginning, installing Netbeans. We want a JDK, a Java development kit, to go along with it because that's where all our libraries and tools will be. So Google Netbeans IDE JDK, and the first option for you should be JDK 7 with Netbeans from Oracle. Let's click on this link and we should have the latest version of JDK with Netbeans. I have 7.3.1. Accept the license agreement and select the package that best fits your operating system. I have Windows 64 and that's what I've installed, but this should work no matter what you have, whether it's Linux, Mac, or an older version of Linux. Next, we're going to open Netbeans IDE and see what we have. One of the many advantages of a Learn Along series is that we get to figure things out at the true beginner space. Before each episode, I try to figure out and understand a piece of code. Every error I make and every question I have and spend hours to research will be presented in a concise format so that in each episode we understand the what, when, where, and how of writing Java code. In the description of each episode, you'll also find tons of links to other great tutorials or to forums with really good answers to tough questions. Alright, so we've opened Netbeans. I always leave this box up here checked so that this shows up on startup. Lots of good tools here for beginners. I actually want to begin by taking a look at some of these features here. I recommend taking a closer look at the demos and tutorials, especially for Java, JavaFX, graphic user interface applications. For now though, we're going to try a sample project. Under sample, select Java, anagram game. Next. And then finish. It doesn't look like much has happened. That's because the project has been opened. We don't want to take a look at the code. The code is here in source packages. We can expand it further and then see static word library Java, word library Java, about, and then the anagrams. We can take a look at the library. This is basically where all of the words are contained in some of the code. We're not interested in this, so we're going to close it out. What I'm interested in is showing you the user interface of this application of Netbeans, our development environment. Let's take a look at these tools here, the hammer and the play button. The hammer is to build your applications and the play button is to run your project. So basically all of the code contained in this project is compiled and then run. Let's go ahead and click on this. And there it is. We see our output that it's run and we see the graphical user interface. All of the code that's been compiled results in this. And we can play around with this, try to guess the words. For now, we're going to close it and we're going to click on the hammer. We want to build our application and this little pop-up box is going to show up. Don't really worry about what it's telling you, just click clean and build. It's going to go through a process and then underneath here, under output, you'll see build successful. The reason I'm doing this is because I want to go over to files, expand anagram game, and select this distribution. If we had not, I guess I should have showed you this before, but if we had not clicked on the hammer and select build, then this folder would not be here. We would see build, NB project, SRC, source, test, etc. However, we did click on the hammer and we did build our application and now it's ready to be distributed, if you will. So let's click on this. We have a README. We can take a look at that really quick. It gives you some information about building a Java application, jar files. Let's close this. This is what I've been looking for, the anagrams.jar. First, we need to understand what a jar file is. Think of a literal glass jar. A jar file, which stands for Java Archive, combines many files into one. Software developers use .jar files to distribute Java applications or libraries in the form of classes and associated metadata and resources, such as text or images. We want to know what happens if we try to run a jar file. The reason being is now that we've built our application, say for example we've been tasked with a project to create this anagram game, and we need to distribute it to our clients and customer base so that they too can play it. Well, let's find out where the anagram jar is. Right click on anagrams.jar, select properties, and under all files, select the three dots to expand it. And this is the file address. This is where anagrams.jar resides. Let's go ahead and open that and see if it runs. Okay, I've navigated to anagrams.jar. A quick caveat, we've installed Java, but in order for someone else to open this, they need to have Java too. Let's see what happens when we double click this. There you have it, the program works and we can play the game. If we were to email this to a client that also has Java installed, they'll be able to see what we see. And if they have the necessary applications, they can even unpack this file and look at the source code or make changes. For now though, all we need to know is that our Java projects have a practical application. We can write the code, compile it, build the application, and then export it as a .jar file. Now it's time to start a new project and write some code. So let's open a new project. Go up here on the top left. You can also click Ctrl-Shift-N, and we'll be taking note of any of the keyboard shortcuts to make our programming life easier. But for now, let's click on this. We want to select Java, Java application, next. Let's leave it Java application 2 for now, or for you it will be Java application 1. We'll change the name later. Down here, create main class. Netbeans automatically creates a new main class for you and names it Java application 2.java application 2. Note the capitalization of letters. That'll be important here in a minute, but for now let's click on finish. There you have it, our new Java application. Again, for you it should say 1. Let's take a look at what we have here. Now in this first episode we're covering the very basics, and I assume nothing about your prior programming experience. So these first lines here, lines 1 through 4, with the / and a star, that is a comment that is ignored by the compiler. Meaning when we run this application, this Java application, these lines will be skipped. Lines 7 through 10 and 13 through 15 are the same thing, and that is what is known as a multi-line comment. If you want to do a single line comment, you can do 2 / as we see on line 17. The first thing we want to do here is to clean up our application by deleting some of these unnecessary comments. Okay, all cleaned up. All I've done is delete the comments. Let's take a look at what we have. Package Java application 2 tells our program to look in this package here. The package Java application 2. We can have multiple packages per project, so nomenclature is important. Public class Java application 2 declares the class as public and gives it the name Java application 2. Notice the capitalized letters. We'll see later that this is important. Down here, public static void main string args in parentheses. This here is the starting point of every Java application we will write. The parentheses after the word main designates this as a method, a building block of our program. For a Java application with multiple methods, exactly one must be called main. The word void here means that our program does not return information upon completing its task. In later tutorials, we'll create programs that do. And now, without any further ado, it's time to begin writing our code. On line 1, we're going to type import java.util.scanner, semicolon. As you notice, Netbeans sometimes fills in the words for you, and at that point, if it is what you're looking for, you can press enter. If it is not, you can continue typing, or you can use the down arrow to select what you want. What we've just done is imported a class called scanner. A scanner allows a program to read data for use in that program. To do this, we have to specify a source, such as an external drive, or as in our case, user input. This is the good thing about Java. Rather than reinventing the wheel, we can borrow from the vast libraries of classes already out there and import it for our use in our program. Let's begin typing out our program here on line 7. Scanner input equals new scanner, parentheses, system.in, end of parentheses, and then a semicolon. Every line of code in Java must end in a semicolon, otherwise we're going to get a syntax error and our code will not compile properly. On a new line, let's skip a line for readability. We're going to declare our integers, our variables, if you will. Integer number 1, integer number 2, integer sum. Let me take this opportunity to explain what this program will do. It will take two numbers and add them together. That's it. A very simple, very easy program, and it does not require a lot of coding. And it will take user input. So basically, you designate the two variables, the program adds them, and then it displays or prints out the result. So what we're doing here is we're declaring our three variables, number 1, number 2, and the sum of these two variables as integers, meaning whole numbers. Now, a variable is a location in your computer's memory where a value can be stored for later use in a program. Let us now write the code that will print out our outputs and that will gather our inputs. So first, system.out.print, parentheses, and then quotation marks, enter first number. Or we should say integer, that way the user knows that it's a whole number, colon, and then semicolon. Number 1 equals input.next, int, next integer, parentheses, semicolon. Skip a line, system.out.print. We don't want sum, we want quotation marks, enter second integer. And then number 2 equals the same thing as on line 14. Input.next, int, parentheses, semicolon. Those of you keen observers out there have probably noticed that this program has been written with quite a few errors built into it. Not to worry, that's been done on purpose as a demonstration. I want to show you that it's okay to make mistakes in the beginning and that you don't have to write perfect code. Mistakes can be corrected as long as we know how to read the error log. So when we try to compile this program for the first 2, maybe even 3 times, we're going to get pesky errors and the program will not work. That may frustrate you, but it shouldn't. Don't worry. Take your time and we'll take a look at every one of the errors we've made. We'll explain it and we'll get the program running. But for now, let's finish our code. The last thing we have to do is add the numbers, which will be sum number 1 plus number 2, system.out.printf. Sum is %d, which is a placeholder for a value, \n, and we'll explain these in more detail here in just a minute once we finish the program and fix the errors we have in it. And that should be it. Okay, at this point, you can see that our environment, the Netbeans IDE, is telling us we have several errors. We have one here, we have one here, and we have one here. Let's read through them. The one on line 1 says incorrect package. The one on line 2 says class interface or enumeration expected. Line 13 says cannot find symbol, method, next int, next integer. So something is going on here, and let's take it line by line. Line 1, incorrect package. That's telling us that the compiler is expecting us to declare where the package is that we're getting our class from in the very beginning. And instead, what we've done is we're importing class scanner. So we have this backwards here. We have an import declaration, and then we have a package declaration. And it's looking at it, it's expecting it the other way around. Here's the reason why this does not work. The compiler literally reads the program line by line, starting with line 1 all the way down to our closing bracket at line 21, which means that everything has to be in its proper order. So what we're going to have to do is copy this, delete it, make sure that package is the first line, and then paste our import declaration on line 2. But we're not done yet. Let's see what happens when we try to compile it. Say, for example, we do it like this, and we don't see this little exclamation mark here, and we press the Run Project or Compile button. It's going to tell us that one or more projects were compiled with errors. We can cancel or we can run anyways. We want to run anyways. That way we can see more details as to what's going on. Down here in our output, we're going to see run exception in thread main java.lang language .runtime exception, uncompilable source code, erroneous system type, java.util.scanner.nextInt, so next integer. Something is wrong with this declaration for enter first integer. Let's take a look. We have two such declarations. On line 16 and 17, we're not getting an error, even though it's the exact same thing. So what's going on? We've put in capital letters instead of lowercase letters, and our compiler does not recognize this. Could this be it? Could just a few miscapitalized letters be the cause of our errors here? Let's try it. Let's try typing in capital I, lowercase nt. Wow, there it is. That was it. It can be very finicky sometimes if you miss a semicolon or if you mistype something. For example, here, Java application and the package Java application 2. It has to be exactly as it is. For example, this has been fixed now and we can compile the program, but let's see what happens if we mess up on our package. Let's capitalize J and let's put in a lowercase j here and see if we can compile it. It freaks out. It literally gives you a lot of errors, and we can spend our time and look at every single one of them, but really that wouldn't tell us anything that we don't already know. Exception in thread main, Java result 1, Java language, no class definition found, error, Java application 2, wrong name. So basically it gives you enough information to tell you that you've put in the wrong name and that it's looking for something that is not there. It's looking for a package, Java application 2, yes, but it's looking for a package with a capitalized J. And here we have it as a lowercase j. So every detail matters. Let's put in a lowercase j and let's fix this. See, very nice. It tells you the exclamation mark. It tells you which line the error is on. And depending on how many lines of code you're dealing with, if you're an advanced programmer and you're dealing with hundreds of thousands or thousands of lines of code, it can be pretty frustrating to try to find one miscapitalized letter. But by looking at the different lines and the error readouts, we can get a better idea of what's going on. So I think it's ready now. I think we fixed all of the errors, and let's see if this application works. We compile it, and yes, great success. Our output says run enter first integer. And let's try it. Let's put in an integer. Let's say 42. Press enter. Enter second integer. So far, so good. The program is running and we haven't encountered any errors. let's do something easy, 5. So the result should be 47. Let's see if it's working. Press enter. Sum is 47. Build successful. Total time 26 seconds. Kind of a long build time, but let's examine this code in more details line by line and see exactly what we did, especially down here lines 19 to 21. So what's going on here? Let's take a look at line 20 and see exactly what's going on. System.out.printf parentheses sum is %d \n comma sum. What we're doing is telling the system to print out the following message, sum is, and then some weird stuff happens. %d \n. The %d is a format specifier, and actually it's a placeholder for an integer value. D stands for decimal integer, comma sum. Instead of sum, think of, imagine 2 parentheses, so let's do this. Number 1 plus number 2. That's literally what that means, because here we've declared sum to equals number 1 plus number 2. Instead of doing this on line 19, we could have included this in line 20 and said comma number 1 plus number 2 to save time and to use this variable sum at a later date or a later time in our program. We can Control Z to undo all of this. Simply say comma sum, and here we're referencing the variable sum. Remember our definition of a variable as the location in your computer's memory where a value can be stored for later use in a program. So in this case, if we were to do something else later on in this program, we can refer back to the variable sum, and it will remember that sum is defined as number 1 plus number 2. And number 1 and number 2 are both defined by the integers inputted by a user. And this in turn is because in the beginning of our application, in the beginning of our program, we imported a class called scanner. And again, as a refresher, a scanner allows a program to read data for later use. And we can specify an external source, such as an external hard disk drive, or, as we've done here, user input. So the program literally reads the user input, stores those values, creates a variable called sum that is defined by the addition of the two numbers, the two integers input by the user, and then prints out the result. Now, I realize the level of detail in this video is probably pretty painful, especially for those of you with prior programming experience, but I want us to cover everything very thoroughly early on so that we're not just mechanically writing things like system.out.printf, %d, etc., but understand what those things are and why they're necessary. That way we can eventually get to a point where we won't need references and can write code freehand. It's then that we'll enter the world of design, being presented with a task and having to write new and original code to complete it. For the time being, though, we'll reference existing code and programs pretty heavily. Well, that's it, folks, the end of the tutorial. If you have any comments or questions, please let me know below. Tune in next time as we begin to cover more advanced Java programming concepts. Thanks for watching, and I'll see you next time on an Ecology Designs production. What's going on, everybody? Boris here at the Ecology Design Studio, doing it bigger and better with a new background, bringing it for you. I want you to go to Google right now and search for the following phrase: dump your loser friends. Follow up to our first talk on broadband. In the first one we covered the Bush administration, and this one we're going to cover the Obama administration. But before we jump in, we just want to go on a little rant and vent. I hate Comcast. There it is, I said it.